Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 14, computing actual lengths from a scale drawing. So classwork example 1 says the distance around the entire small boat is 28.4 units. The larger figure is a scale drawing of the smaller drawing of the boat. State the scale factor as a percent and then use the scale factor to find the distance around the scale drawing. So what we need to do first is find a distance of one of the sides. Obviously we can't do an arc because it's not easily measurable, so I'm looking for something that has a straight edge and count the distances that are right on corners. So I'm looking for integer values of distance. So to start, I would look at this small boat and count from here 1, 2, 3, 4, 5, 6, 7, 8. That is a distance of 8. So if I count on the bigger boat, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22. Okay, so once we do that, then we have scale factor is quantity equals some percent times the whole. The smaller boat is the whole. So the smaller boat is W. So that is going to be some percent times 8 equals the bigger boat. Divide both sides by 8, and we find the percent. Okay, so I've got this new tool here that I'm going to use. Okay, so I have an online graphing calculator, TI-84 Plus Silver Edition. So if you have a computer and you would like one of these calculators, but you don't want to spend $120, then you go to just Google Wabbit EMU. And there's a video on how to install this on your computer for free from Texas Instruments. Okay, so now I'm going to take 22 divided by 8. And I get 2.75. So my P is 2.75. Well, that as a percent is 275%. Because of percent, you move the decimal 2 places to the right. Okay, so we've done part of it. State the scale factor as a percent. This is done. The scale factor as a percent is 275%. So this bigger boat is 275% larger than this boat. So we scaled this up 275% to get here. Now it says to use the scale factor to find the distance around the scale drawing. So the smaller one was 28.4 units. So now all we have to do is take that 28.4 and multiply it by 275%. Okay, and that would be 28.4 times 2.75. So if I go back to my Wabbit and I multiply this 2.75 times 28.4, I get 78.1. So the distance around the larger boat is 78.1 units. Okay, so these are the two values that they asked us to find, and that is example 1. Exercise 1. Pause the video, see if you can do this, then come back and we will check your answer. Okay, so here we go. The length of the longer path is 32.4 units. So from here up to here, over, up here is 32.4 units. The shorter path is a scale drawing of the longer path. Find the length of the shorter path and explain how you arrived at your answer. Okay, so what I need to do is find a distance that is measurable. Diagonals are difficult. You'd have to use the Pythagorean theorem and create a right triangle. So I will look at horizontal or vertical distances. Either one will work. and I will use this one here. So if I start here and go to here, notice they're both on corners of the grid, which means they're integer values, and that is a distance of 1, 2, 3, 4, 5, 6. So this is a distance of 6 units. And if I count the same piece of the scale, that is a distance of 2. So quantity equals percent times whole. The whole distance is the smaller one, 2. And that equals a percentage of the whole, which was 6. Not the total, 6. So if I divide both sides by 6, I get VP to equal 1/3. So that is approximately, actually let's just leave it as an exact, I won't use decimals. That is 33 1/3%, because 1/3 is 0.3 repeating, so that's 33 1/3%. So in other words, this scale is 1/3 of that scale. So now I take that 32.4 and multiply it by my percent scale. And 32 times, or 32.4 times 30.33 repeating, okay, and that's repeating. So I'd put that in my calculator as 0.3, well, multiply it by 33, or 0.33 1/3. So 32.4 times 1/3 is what I could do, because 0.3 repeating is 1/3. So if I go to my calculator and I take 32.4 and multiply it by 1/3, like that, I get 10.8 units. Okay, so this total distance from here over to here, up to here, and over to here is 10.8 units. So this length here is 3, that's 2, so that's 5. And this is, that's a decimal, and so is this, because they're diagonals. And they total 10.8. Example 2. Time to garden. Sherry designed her garden as shown in the diagram above. The distance between any two consecutive vertical grid lines is 1 foot. Okay, so from here to here is 1 foot. And the distance between any two consecutive horizontal grid lines is 1 foot. So, well, actually I did horizontal already. The vertical, they said first, that's 1 foot. And the horizontal is 1 foot. So each one of these squares is a 1 by 1 or 1 square foot. Therefore, each grid square has an area of 1 square foot. There it is. After designing the garden, Sherry decided to actually build the garden 75% of the size represented in the diagram. What are the outside dimensions shown in the blueprint? Okay. So what we need to do here is first figure a scale factor. Since the smaller path, hang on. Let's count the lengths first. So the blueprint dimension, this is the blueprint. I want to know what the length is, and I want to know what the width is. So if I count the length, it's from here all the way over to here. And that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll mark 10 so I don't have to start over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5, 6. So that's 26 units, which is 1 foot, so that's 26 feet. The width is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So from this point to this point is a distance of 12 feet. Okay. So the outside dimensions shown in the blueprint are 26 feet by 12 feet. B says, what will the overall dimensions be in the actual garden? Write an equation to find the dimensions. So actual garden dimensions will be 75% of the blueprint. So I'm going to take the length and the width and multiply them by 0.75. Okay, so the length of the scale drawing, which will be the original, or the actual, I mean, when we create it, would be 26 feet times 0.75, which is 75% or 3/4. I don't want to use a decimal and a percent. 75% is 0.75. Okay, and it's easier to use fractions when we are dealing with something like that. We can just put that in our calculator, but I'm going to do it this way. 26 times 3/4. And this will reduce to 2, this will be 13, and 13 times 3 is 39 halves, which is 19 and a half feet. Half of 39 is 19.5. So the length equals, I should have L equals on all of these, and then I'm going to do the width. So the width equals 12 feet times 0.75, which equals 12 times 3/4, and think of that as over 1. And that 4 will reduce the 12 to 3, so our width is 3 times 3, or 9 feet. Since the scale factor was given as 75%, each dimension of the garden would be 75% the original. So the actual length of the garden is going to be 19 and a half feet by 26 feet. I'm sorry, 19 and a half feet by 9 feet. Okay. C, if Sherry plans to use a wire fence to divide each section of the garden, how much fence does she need? Okay, so that's perimeter, and she wants to fence each portion. So now we have to find the distance around all of these. So I'm going to copy this to the next page so we don't have to keep going back and forth. Okay, so here we go. First thing I'm going to do is just count the units. So if I go back to the original, it was 26 by 12. Okay, so this is 26, and the whole thing is 12. And then we're going to section this off. So we know that this is 26, and this looks like 1.5. We'll call that 1.5. So the corn the perimeter of the cornfield is going to be 26 by 1.5. So remember, perimeter is 2L plus 2W. So therefore the cornfield is going to be 2 times the length plus 2 times the... Oh, before I do that, we have to scale it. I have not scaled all these portions. So let's just wait, and let's continue counting our values for all the sections. So the peppers, 1, 2, we're going to do these in red. 1, 2, 3, 4, 5, 6. Peppers are 6 by, we're starting on the half. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the pepper section is 6 by 9 square feet on the drawing. The beans are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Green beans are 14 by 1, 2, 3, 4. Oh, that's a half. So 1, 2, 3, 4.5. And the squash is 14 length because it's the same as the length of the green beans. 14 by 1, 2, 3, 4.5. So the green beans and the squash are going to have the same perimeters. The tomatoes are going to have the same perimeter as the corn. So that's going to be 1.5 by 26. And the lettuce is going to be 4.5 plus 4.5, which is a length of 9, which is the same as the peppers. Okay, so there's all our measurements. So what I'm going to do first is I'm going to calculate 26, all these lengths by 3/4. Okay, so we're looking for a total amount of fence. So if we're looking for a total, we can just calculate the total distances of all these areas. So we have a 26 here. We have 26 here all the way across. 6 plus 14 plus, this is a length of 1, 2, 3, 4, 5, 6. I didn't label that. Okay. But if you're thinking of totals, 6 plus 14 is 20 plus 6 is 26. So every horizontal line is going to be the total length of 26. So we have 26 here, 26 here, 26 here, and 26 here. So that is 26 times 4 plus. So I've already done this line, and this line from end to end. Okay, and then we have a height of 12. Well, here's 1, here's 2. So we have 12 times 2 plus we have 9 times 2. So let me just mark this up as we use them. I put X's here, but let me do this. I've done that, I've done that. This is the 26 times 4. Okay, we've accounted for all of that. We've accounted for the full sides of 12 times 2. We've accounted for the 9s. Now these 14, this is 14 right here. So that's going to be plus 14. Plus, and then we have these 4.5 lengths times 2, which is 9. So there's 2 9s this way. And we've already accounted for those, didn't we? 4.5 times 4, or 9 times 2, and 14. So that's it. So this is the total. So we just want to add this up. Okay. So when I add 26 times 6 times 4 is 24, carry the 2. 8 and 2 is 10, that's 104. This is 24. This is 18, and this is 14. 4, 8, 16, 20, carry a 2, 2, 4, 5, 6, and 1. So the total perimeter equals 160 in the drawing. So a real quick way to find the perimeter of the original, or the actual, the new drawing, or not drawing, but out in the real world, the actual garden, would be the 160 feet times 3/4. So the actual garden would be 160 times 3/4. Four goes into 16 4 times, so 40 times 3 is 120 feet. So she will need 120 feet of fencing to make this garden in the real world. Okay? Example 3. Before I go to example 3, though, we have to do part D. Part D says, if the fence costs $3.25 per foot plus 7% tax, how much would the fence cost in total? So $120. So the total cost is the amount of fence times the price per foot, which is 3.25 times the number of feet, which was 120, plus 7% of that. So I can multiply that whole thing by 107% or do it individually. Let's calculate the cost first. So the cost would be 3.25 times 120. $390. And then I have to multiply that by 1.07. So now I take the $390 times 1.07 to get my tax. I will just do this manually. 7 times 0 is 0. 9 times 7 is 63. Carry the 6. 7 times 3 is 21. Plus 6 is 27. So the tax is 2730 plus 390. And that should get, if I did this right, $417.30. Let me just make sure. 390 times 1.07 is $417.30. Okay, now example 3. Racecar number 2 is a scale drawing of racecar number 3. So this is the original, or racecar number 1, I mean. This is the original, and this is the scale. So obviously we went from smaller to bigger, so my scale factor is going to be greater than 100%. So it says the measurement from the front of the race car number 1 to the back of the race car number 1 is 12 feet, while the measurement of the front of the race car number 2 to the back of the race car number 2 is 39 feet. If the height of the race car number 1 is 4 feet, find the scale factor and write an equation to find the height of the race car number 2. Explain what each part of the equation represents in the situation. Okay, so we want to find the scale factor, and scale factor is some quantity equals the percent times the whole. Okay? The quantity is the larger value that we're looking for. Our scale is always the quantity. So 39 equals some percent times the original 12. Divide both sides by 12. 12's cancel, and I get P to equal 39 divided by 12. And it's 3.25, which is 325%. So it's a scale up of 325%. Okay. So now we have to come up with an equation to find this value right here, the height of the scale. So height is going to equal the original height, 4. So let's just, instead of using the word height, let's use h for the scale of the height. We're trying to find h. This is h. So h equals 4 times our scale, which is 3.25. So there's our equation. So h is going to equal 5 times 4 is 20, 4 times 2 is 8, plus 2 is 10, 4 times 3 is 12, plus 1 is 13. So the height equals 13 feet. Okay, exercise 2 says to determine the scale factor and write an equation that relates the height of side A in drawing 1, the height of side A in drawing 1, and the height of side B in drawing 2 of the scale to the scale factor. The height of side A is 1.1. Explain how the equation illustrates the relationship. So we do quantity equals some percent times the whole. The quantity in this case is our scale, the larger, 3.3. Now we want to look at our givens that we know. We know the width on both. So the quantity is 3.3 equals some percent times the original drawing's width, which is 2. Divide both sides by 2. These cancel, and we find P. .3 divided by 2 is 1.65. So P equals 165%. Okay. So now that we've found the scale, now we can answer the question using our P. So now, what's going on with my pen here? Okay, it's not giving me the pen logo, but it's okay. So now we want to find B. So what we want to do is sum quantity equals percent times the whole. The quantity in this case is going to be our scale value, just like before, B. So that's going to be our unknown. So Q equals our percent, I'll do it as a decimal, 1.65 times the whole, which was 1.1. So Q is going to equal 1.65 times 1.1. 1.65 times 1.1 equals 1.185. 1.185. And it's centimeters. So Q is actually my B. So let me just change that to B now. That answers the question. B equals 1.185 centimeters. So it says to explain how the equation illustrates the relationship. So once we determine the scale factor of 165%, we can write an equation to find the unknown height of side B using that percent by multiplying the scale factor of the corresponding height to the original drawing. Exercise 3. The length of a rectangular picture is 8 inches. Okay, so I always like to draw a diagram. So the length of a rectangular picture is 8 inches. And the picture is to be reduced to 45.5% of its original picture. So again, we're going to draw another picture, and it's a smaller rectangle. That's better, okay. So this is a scaled down version, and it's going to be 45%. So this doesn't look like it's to scale. I'm not going to do it accurately, but you get the idea. We're doing a smaller. This should be half the distance of this, or less actually, because 50% would be 4. So this is going to be less than 4, knowing that 45.5%, the original picture. Write an equation that relates the lengths of each picture. So I'm trying to find this, the length of the scale. So the equation is going to be, my computer's messed up, so just a second. All right, so sorry about that. My computer is messing up. So we take the 8, the original, okay, so let's write Q equals some percent times the whole. We're trying to find a quantity X equals, our percent is 0.455. That's 45.5% times our whole, which is 8. So when I get my calculator out, I do 0.455 times 8. Too many fives. 0.455 times 8 is 3.64, was it? 3.64 inches. So my explanation will say the length of the reduced picture is 3.64 inches. The equation shows that the length of the reduced picture is 3.64 is equal to the original length, 8, multiplied by a scale factor of 0.455. Okay, that is the end of lesson 14. Review the lesson summary and go to your problem set.